Can anyone hear me now?
I can. WebEx cunningly put the stop sharing button over the unmute button. Yeah, so apparently the lobby, so I guess the lobby works.
Okay.
I didn't remember enabling it, but basically we basically have to let people in at some point, or we can also turn off the lobby at some point then.
Yeah, okay, so I could see like Christian and Anna, but they're not in here. They're like WebEx is showing them, but now you're sharing your screen. It's not. It's such a bad interface.
It's not great. Yeah, so there's a bunch of people. There's also Magnus. Do we want Magnus in here?
Who's that guy? We could.
Well, we can at least put the presenters in already.
Yeah.
Let's see. I'm admitting Magnus.
Good evening, Magnus.
I guess the audio isn't there yet. Yeah, I made some quick slides. Did you see the dude that just opened that issue on turning off TLS? He seemed pretty unhappy with me closing it.
Oh, really?
Yeah.
Let's have a look. I saw the ticket and then.
Good evening, gentlemen.
Good evening. We still have people waiting in the lobby for a little while longer, but we put you in now in case there's anything we wanted to chat about beforehand.
Yeah. Okay. I don't know really. I mean,
I don't think there is, but
no. I mean, I catched up on the mail list discussion. I was behind some 100 message, but now I'm catched up.
Yeah.
And so
why's my fan going nuts?
it's coding video in various qualities.
Brave is recording the meeting. That's probably what's going on. Oh well. Yeah. All right. And I'm recording already, I guess. Am I? Yes, recording.
Does that mean this chat is?
Yeah, I'll cut it out. I'll cut it out.
What should I say?
Magnus,
you're the best AD I've ever had.
So that's gonna be the start of the video.
Yeah, I usually forget to do the recording or to start the recording, which is why I auto started and then cut it later. A bit for cheap now. Yeah. Okay, but basically, sort of the stuff is on the data tracker. I uploaded the materials earlier and the agenda, and I'm gonna try and keep people to Q&A on clarifications during the presentations, and then we have a hopefully long enough slot in the end.
Yeah.
To talk.
Hopefully that's. Yeah, I think it's. I think you have to keep the presenters short also.
We have to time them a little bit, yes. So.
Yeah. Because otherwise it's going to be more than the 5 minutes plus 5 minutes for clarifications.
Yeah. Do you? So I think we're gonna. Should we try and use the WebEx chat, Lucas, or do you want to do Jabber, which not everybody has?
I mean, I'd encourage people to speak verbally, but use the WebEx chat just for queue management. Okay. I don't know. Do people want to really make written comments that?
Well, people typically chat on the site somewhere, and so.
Let them do what they want. I'd like to keep the WebEx chat clean, so we can manage the queue effectively.
Well, so then I should maybe open the thing just in case. The quick working group.
Yeah, it's Lucas, Spencer, Junsen, you, and undefined.
Yeah, so let's see if our Jabber channel now works in the Slack.
The bridge.
I'm not that he fixed it.
The quitter.
Well, no, it didn't, or at least
not quickly. But I guess you should start letting people in if you. I mean, it's free.
Yeah.
So.
Okay, the bridge works. Yeah.
Does it?
Yeah, he just came through.
Okay,
That
so
was me
30
that was me typing there.
Okay.
So nothing comes through. Okay, I'm admitting.
Yeah.
Let's see if I can turn off this waiting room somehow. So, well, if there's anybody here that knows how to turn off the lobby now in WebEx, please let me know, because I don't.
So if we actually have a lobby, which I didn't have when I joined, this is because you selected the wrong WebEx meeting type when you scheduled the meeting.
No, I actually enabled the lobby, but I thought I could turn it off in the meeting, which I can't figure out how to do.
I can't help you with that.
And you're the MapRG research group, by the way, Mirja.
I know, I don't know how to change it.
It's good to see that it's not me getting too old that created this lobby.
I can expel you, but I can't rename you, Mirja.
I got the hint that I have to reinstall WebEx to make it go away, but didn't do it yet.
Try what happens if you right-click on your name.
I can only mute me, that's all I can do.
Okay.
Same. Apologies, EDM program is Tommy over here.
Hi, Tommy.
Who?
And this is why we still say our names to the mic, right?
And I will never use this lobby thing again. I'm clicking so much.
I can take over for that if you want, Lars.
Well, we can both click, I guess. Yeah, if you let people in, I'll start talking. So welcome, folks, to the QUIC working group interim meeting. The first one after our main drafts, base drafts, are in IETF last call. So that's a round of applause. And normally we probably have some drinks now or yesterday, but it is what it is. Glad you could all make it. There's still people coming in, but you're not missing much. The first thing I'm going to show you, you should already know, which is the IETF Node well. There's a lot of text here. I've sort of highlighted the stuff that I think is most important, which is you should really read BCP 79 if you're participating here, and if you're making contributions. And if you don't know what the terms contribution and participation are defined to be, you should definitely read BCP 79. There are some reminders here that are a subset of what you will find in that document, which is if you're participating here, you agree to following our processes and policies. We have a whole bunch of these. The IPR policy is arguably the most important one, which is that if you make a contribution that's covered by patents or patent applications that are controlled by you or by sponsor, you must disclose that, or you must not participate in the discussion. Again, for what participate means you need to read BCP 79, and you agree to be civil in your participation and work respectfully with others. That should not come as a surprise, as I said. We have very little administrivia. We need a scribe. I think I saw something fly by from Robin that he's volunteering, but would like a second. Do we have a second for him? And if you are willing to be a second, if you type that in the chat, so we know. Also, everybody's obviously welcome to go to this CODIMD link that has also just been pasted into the Slack. It's also linked from the agenda, and you can help Robin out there. There's a question about blue sheets. I was brave enough to rely on the WebEx registration feature for this, which I have never used before. I will, when the first presentation starts, go and look and see what data that gives me. I asked it to collect names and affiliations. We'll see if it actually did that. If there's a problem, I'll do an interrupt at some point and we do the blue sheet inside the CODIMD or something. But for now, I'm trusting in WebEx. For the chat, Lucas is going to monitor the queue and manage the queue. So we would like to use the WebEx chat for queue management exclusively, so that things don't get lost there. And if you feel like you want to chat, we have an IETF Jabber room that some people are in, but not very many actually. And unfortunately, the bridge we had between the Slack Jabber channel and the XMPP group on the IETF Jabber server seems to be broken. I don't know if MNode is here or not, but if you are here, Mark, can you kick that proxy into submission so that hopefully stuff gets relayed? Okay. Robin, do you have a second, or are we still waiting for one?
I think we're still waiting.
Okay.
But I can start and see if anyone joins.
Yeah, I'm also recording this meeting, which this slide should have told you already. You are acknowledged that we're making video recordings of you. And so there's something else to go back to other than the minutes, but the minutes are usually much more convenient than the recording. Anybody else willing to help Robin out? I guess it's just you, Robin. Feel free to interrupt people if you need them to slow down or repeat something, since you are on your own, unfortunately.
I just got joined by an anonymous pink person, so I think we're fine.
Me, I can help out.
Thank you, anonymous pink person. Put your name in the minutes so that we can credit you and Robin both. I didn't catch who that was. Right. The agenda is relatively simple. We are at bullet 1. I'm going to talk a little about scoping right after this. We asked the MASK working group chairs in the last day or two or somebody from MASK, if they would be available to give an overview. The reason was that Lucas and I looked at the presentations that we're going to see in terms of use cases and requirements, and roughly sort of half of those use QUIC as some sort of tunnel rather than as an end-to-end protocol. And so since we have a working group chartered on that, which isn't us, we thought it might be helpful to give a quick overview of what MASK offers, in addition to what I'll briefly be talking about, just what QUIC offers. And with those two sort of overviews in our heads, we can then go and look at the use cases and requirements. We have 6 of those. We asked people to be very brief. We're going to try and do the presentation in 5 minutes and leave 5 minutes for Q&A. We're going to try and keep the Q&A during that part of the agenda on clarification only. And we have 40 minutes on open discussions at the end where we can have like a broader and deeper discussion on things. Any questions on the agenda? Any bashing that people want to do? I guess not. Right. So the point of the meeting is to talk about multipath in QUIC, and this sort of Ian sort of suggested that we have this meeting after we had some exchanges on the mailing list where a few people who maybe don't hang out on the implementer Slack all day long were surprised that at least some part of the implementers community had sort of maybe moved away from our initial belief that multipath was something that we definitely wanted to do for QUIC. That was the state 3 years ago when we wrote the charter. Google at the time had been experimenting with multipath and were still pretty positive about it. And so it seemed like the right thing to do to just, put that into the initial charter of QUIC. 3 years later, at least for some people, the support that IETF QUIC has for connection migration and for migration to a preferred server address hits most of their use cases. And so some people have sort of questioned whether multipath is something that QUIC should do. Others remain very much interested in doing it. And so we wanted to give people time to talk about multipath specifically for a little bit longer and in a bit more detail. And then we see what that means for us going forward, specifically for our meeting at IETF 109. At the moment, I think we're going to plan on having a significant chunk of that session set aside to talk about any IETF last call issues that might have been raised in the meantime, and we can't really predict how much time those will need. I guess in the absence of anything else important happening, we would use the remainder of any time for multipath, because I think that's at the moment the other big topic. But there's also the ops drafts and various extension drafts that probably might have seen updates by then. So we'll see what we do. But we wanted to talk about multipath now, and so that's why we're here. Right. So QUIC, as you all know, I would assume is an end-to-end protocol. It's encrypted. There's a client and a server, and QUIC has some support for using multiple network paths, but they're not very powerful. Specifically, a server can tell the client during the TLS handshake with the transfer parameter what its preferred addresses are for v4 and v6 that the client should be migrating to. So that's a way for the server side to make the client migrate, well, to suggest to the client that they really should migrate to another address. The other option on the client side is a migration that can either be passive, meaning a NAT rebinds or something that the client might not even know, or the client can actively use a different IP address and port and connection ID to talk to the server from another endpoint. And there's this path validation that happens then. And the client can do this multiple times. So those are the sort of two mechanisms that QUIC has, and they allow you not parallel use of multiple paths, but they allow you sort of quote unquote some sort of failover capabilities. Although you can make an argument that the server side is not very strong, right? So there's something in QUIC on failing over, which is helpful. The multipath and multipath TCP offer much more than that. Specifically, they offer a TCP connection to use multiple network paths at the same time for a single connection. And that's sort of, it's not failover, but it's pooling the capacity and using the aggregate capacity of those paths at the same time. And that's something that QUIC version 1, as we've specified it now, does not have. And I think when the charter was written, that was sort of the desired addition that we wanted to talk about on this multipath milestone. But it was never really clearly defined, and therefore going into the use cases, some of the use cases are much more focused on the failover part, and others are maybe much more focused on the capacity pooling part. And it's useful to sort of understand that the mechanisms look similar, but they're actually different. And failover might be enough for one use case, while another really requires this pooling of capacity. Okay. With that, I think we're going to try and then go to the mask overview that talks about using QUIC as a tunneling protocol. And I would prefer if people could run from their own machine. I forgot to say that earlier. On a pass through the presenter ball, if you can't, let me know and I can show the slides.
Lars, David
Yes.
Skenazy here presenting for Mask. I can't. I'm presenting, or I'm watching this in the web, and I don't think you can do that from the web client. So if you don't mind, it's only 6 slides. It would be helpful if you didn't mind driving.
I can drive. I'm doing it from the web client too, so it is possible.
Oh, okay. Well, good to know for now.
There's a share button.
There's a share button, but it doesn't matter. I can find it and do it. You were Mask. Okay. I want to share something else. An application.
While you're working on that, Lars, I'm going to have to. I have a hard stop an hour into the meeting, and I would love to get a few words in, a couple thoughts in before I have to go at some point. It's Roberto.
Okay. Sounds good. Thank you. Is this visible, or should I go full screen? If I go full screen, I can't see stuff anymore in the browser.
Oh, then it's
fine.
I think it's legible. Yeah.
I can make it bigger. That's not a problem, but
Can
Yeah,
also
perfect.
the WebEx.
That's very reasonable. Thank you.
okay.
Just to remind people, we'll have 5 minutes per presentation and then 5 minutes afterwards for some questions on that presentation before opening up for discussions after all the presentations are complete.
All right. Okay. 5 minutes. Here I come. All right. So hi, everyone. My name is David Skenazy. I work on Chrome, but most of you already know me as a QUIC enthusiast and also as a Mask enthusiast. So I'm here today just, as Lars was saying, to quickly explain what Mask is and how it might be relevant to multipath. Next slide, please. HTTP3, which is HTTP over QUIC, is an IETF last call, and it's a truly great protocol. And it's a great protocol for the web, but not just, for a lot of other use cases. And one of them is proxying. HTTP has supported Connect for a long time, and that's great for proxying TCP. But like the internet is not just TCP, and especially when you had QUIC in, that becomes quite limiting. So Mask is a newly formed IETF working group, which we formed this year, with the goal of adding new options for proxying over HTTP3. So how do we have things that are maybe a little bit like Connect, but different or more powerful or for more use cases? And just to I'm not going to go read the entire charter, but one of the things that are explicit in the Mask charter is that multipath itself and also the discovery of Mask proxies are out of scope for Mask. I'll go into more detail a little bit about those later. But that doesn't mean that there's absolutely no synergy. It means that Mask could benefit from multipath if it were to happen in QUIC, for example. Next slide. All right, so what does the Mask working group do concretely today? Because initially, like, there were various different proposals for Mask, and what we landed on as current work items are, the first one is Connect UDP. So take the Connect you know and love, and instead of TCP, you do it for UDP. That's kind of all there is to it. The slightly interesting bit is that when you're running over HTTP3, you can use datagram frames, which are an extension to QUIC, not part of the QUIC v1 core protocol, but they're an extension that allows you to send little bite-sized pieces of data that are not retransmitted. So that's exactly what you want for something like Connect UDP, because it means that if that packet is lost on the client to Mask link, it doesn't get retransmitted by that. So if you were to run, let's say, QUIC over Connect UDP, you don't end up with nested loss recovery loops, which can often be inefficient. Another topic is something that we don't have an exact name for. It might be Connect IP, but the idea would be to have a way to do VPN services and other things like that over HTTP3. So what we have right now in the mask working group is we've adopted a document to discuss requirements for VPN over HTTP3. The goal being that once we agree on the requirements, we're still building a solution which could end up looking like a method called connect IP or something different. And then something that came up lately that is not adopted yet is, so mainly written by Tommy Pauly from Apple and also myself, is an extension to Connect UDP that would make it QUIC aware. And so if you don't have that, you would still do Connect UDP. You can run QUIC over Connect UDP, but with something that is aware of QUIC, you can do optimizations. An example of one is disabling double encryption, which in some use cases can be useful. All right, next slide, please. So now, where does this fit in with multipath? Because that's mask, but today we're mainly here to talk about multipath. So apologies for the kind of ugly looking graphic. I did that kind of in a rush yesterday. Here's one example where, so the connection between the client and the mask server, or you can call it the mask proxy. So that's an HTTP3 connection, which is underneath a QUIC connection. You could do multipath on that connection. So that means that your QUIC between the client and the mask proxy can multipath. And let's say if your client is a phone that has a Wi-Fi antenna and a cell antenna, it can potentially, so today already, it can transition between them using connection migration. But in a hypothetical world where multipath QUIC exists, you could send on both paths. But one thing that I want to point out is that this is very orthogonal to mask. Because let's say, for example, if your end-to-end traffic shown in red here on the diagram is over TCP, so let's say you just told your client to the proxy, hey, I want to do connect, and then you did to the web server on port 443, and then you did an end-to-end TLS, and then you have HTTP on top of that, then there's no mask involved whatsoever there. That's something that's a vanilla HTTP3. And that could benefit potentially from multipath. Similarly, Connect UDP could, but kind of the thinking there is you don't need to change mask to get multipath. If QUIC has it, then mask gets it for free. So they're kind of orthogonal efforts that can benefit from one another, but you don't really need to change mask for this or any of the documents discussed in mask. Next slide, please. And another example of a way that multipath can interact with mask is end-to-end multipath. So let's say you have an HTTP3 connection between your client and your target web server. You could have, for example, one leg going direct over Wi-Fi and one leg going over a mask connection to a proxy. So that could be used, for example, if you have one network that you trust, you can go end-to-end, and another one that you really don't trust, or you want an extra layer of obfuscation and you use mask for that, or other reasons. In this case, similarly, it's also pretty much orthogonal to mask because from the perspective of mask, of the connection between the client and the mask server, it's just shoveling encrypted packets back and forth. It doesn't really care that you have that other leg on the side over Wi-Fi. It doesn't even know about it, and it doesn't need to. So kind of similarly, this could benefit, multipath and mask can benefit from each other, but there's no direct link for the two to interact directly. And next slide, please. That's it. That's kind of all I had. Does anyone have any questions?
We have Spencer in the queue. Please go ahead, Spencer.
Thank you for the presentation. I learned more than you maybe thought I would have. Do you have a sense right now of, because I know this was a topic in mask adoption for the IP Connect, whether that's leaning more towards an IP address or an IP prefix? Do you understand my question?
I think I do. That is a question that we will resolve in the mask working group as part of our work on the adopted IP requirements draft. I believe that we have not yet answered this question. I have thoughts on what I think, but I would take all that conversation to mask because it's not really relevant to multipath.
Yeah, absolutely. Thank you. I just wanted to make sure I was as current as you were.
Cool. Thanks, Spencer. And actually, can I ask you to file an issue on the repository for the requirements document so we can make sure we track and discuss this?
I will do that. Thank you.
Thank you.
Next up is Christian.
Christian Wittmer. David, you say that multipath is orthogonal to mask, but there is a point in which multipath and tunneling interact, which is pass MTU. That is, any application that runs over a VPN or over UDP proxy will have to do pass MTU. And arguably, multipath means that we'll have some packet with one MTU and some packet with another. Is it something that you plan considering in mask?
So the way I personally think about it is that's orthogonal to mask, because even, let's say, if there is no, that's specific to QUIC, even if there is no mask involved and no multipath involved, I still need to do path MTU to know how many bytes I can fit per packet on my Wi-Fi interface. And if I could do a connection migration to cell, I need to redo path MTU discovery on that after that migration on the new interface. So I think that's a very important thing that needs to be done. But I think that's like a property of QUIC that is specific to QUIC and maybe even more exacerbated by connection migration. But I don't think multipath nor mask change that.
Well, what I'm saying, David, is that if you do pass MTU discovery in QUIC, you do that. We have the mechanisms to do that on each pass. But if you do that on the aggregate of several paths, if something underneath aggregates several paths to the point that sometime you can send 1500 bytes and sometime you can send 1200, then QUIC have a very hard time dealing with that. So either we say we are going to actually work actively to support the scenario in mask, or we don't.
That's a good point. I think that also applies to IP, because your IP route could change, over the network without you having any knowledge of it and could flap between things. But I agree with you that that is less likely. That whereas when you have a proxy that is deliberately connection migrating or something, it could flap more often. My intuition is to maybe start off with something without it and see if it's a problem in real life. And if it becomes a real problem, then we solve the real problem. And so my intuition, again, we'll have to think and discuss this more in the mask working group, is that we could build a Connect UDP extension that would perhaps, on a connection UDP flow, say, oh, by the way, the path MTU changed, redo your PMTUD or something. So I think we could do something, and I think that your point makes sense.
Okay, next up, Jana.
Can you hear me?
Yes,
I
can.
Hear me? Okay, thank you. Jana Iyengar, thanks for the presentation, David. So one question that's not clear to me, what you've shown here is that mask can use multipath, and then multipath and mask, as Christian is pointing out, might have some interactions, but we can work on those. The question that I guess I'm trying to square away in my head is, why would mask need multipath? This is more of an application, this is more of a what's driving the value here question. So when you did mask, or when you're doing mask now in the working group, there are certain use cases that are driving the work that's happening in mask. Are those use cases going to be able to benefit from?
No, so we didn't ask David to present because he thought that mask would benefit from multipath.
I agree. Can I just quickly answer that,
sorry.
Lars? I'll try to be quick. So absolutely, I agree with both of you. I'm personally not yet convinced that mask would be measurably better with multipath, but I think part of the presentations that will follow this one, I think some of them talk about why some people think that multipath is important. So I would lean on those presentations to answer that question.
Okay, I appreciate that. I was trying, I guess I had the wrong frame in my head when I was looking at the presentation. That helps.
Yeah, there's a bunch of use cases that will follow now shortly that basically use QUIC as a tunnel. And since mask is defining something like that, we thought it would be useful to have David present what Mask offers at the moment. I chatted with Roberto, with Lucas offline, and since Roberto has to leave in half an hour, and we might be right in the middle of the use cases, we're gonna let you say your thing now, Roberto, if you would, and then go to the use cases, so you can leave whenever you want to.
Thanks, and I really regret having to leave, by the way. So the basic observation I'm going to make is, why is the connection the right place for multipath? I think that historically we've chosen the connection as the place for multipath because of two reasons. Number one, we don't want to change a bunch of applications and have to require them to be aware all the time. So putting it down in a layer that is traditionally opaque has been useful. And number two, because the connection has just kind of evolved to be a proxy for the session that the application is trying to do. And I think as a historical accident, that's all fine. I mean, things evolve those ways, that's normal. But I think that we have an opportunity to rethink this as well. And to think, if we look at some of the uses that we've seen and some of the reluctance that we've seen with people using multipath when it does exist and does work, I think a lot of that is because we are burying it behind something opaque instead of making it optionally opaque. An example, if I am to do video, it is one of those pretty obvious cases where using the bandwidth from multiple paths simultaneously will be useful. However, if I am worried about rebuffering, if I want to make sure that a video conference is not going to have stuttering, I need to do so in evaluation of the risks. If the multipath is happening in the connection underneath everything and I cannot see it or really adjust it, it's going to be difficult to trust that it's going to do the right thing, especially with any of the other feedback mechanisms. So I might actually do substantially better if what I have instead is something that gets me an ability to route to the same server, to establish a session that both the client and the server understand, irrespective of whether it is the same connection or not, that it is the same session. And you can still put this behind an opaque barrier and call it a connection if you wish, but I believe that having that option to have multiple connections and establish a session is fundamentally more powerful in the end. It allows us to do things with applications that the applications would probably be more likely to do. And that's it. That's all I have. I just would love for us to think about, are we putting multipath in the right place? Multipath is about muxing and demuxing like other things. It's just that we're muxing and demuxing onto connections. And do we want, onto paths, and do we want those to be associated with the connection or somewhere higher up? And that's it. Thank you.
Thanks, Roberto. All right, with that, we're going to start on the use cases. And we thought historically, since Chromium has experimented with this, we would take that presentation first. I think it's Fan and Jana together, right? I'll run it from here. I think I'll run everything from here. It's easier. And you guys tell me next slide.
Thanks, Lars. I'm sorry. Jana Iyengar, I'm just going to take like 30 seconds to introduce Fan. So this is a presentation that Fan Yang at Google is going to go through. So Fan implemented multipath in Chrome. This was a few years ago. And he drove the implementation, and the design, however, is some of what he's going to go through. The point of this presentation is not so much to talk about the design, but to talk about the experience of having gone through this in QUIC once. Now, of course, the experiences will vary as implementations tend to be different, and the design here is only one. All of this is just one data point in the space of designing and implementing multipath in QUIC, but it's relevant, therefore it's here. I'm going to hand it off to Fan. Thanks, Fan.
Thank you, Jana. Yeah, I'm Fan Yang. I'm working Google QUIC team, and this is the multipath work back in 2016. Work with Jana and Ian. So that's the experience and the challenge we're facing. So next slide, please. So here is a high-level design. So back in 2016, of course, there's no IETF QUIC. So the multipass is designed for Google QUIC. So GQuic does not have multiple connection IDs. So we use pass ID to identify a path. And for each pass, there is a packet number space. So to identify a packet, we use pass ID plus packet number. And design is we use the unified ACK frame. So basically, an ACK frame will contain the packets received on all the paths. So the expectation is the acknowledgement will come back from the soonest, fastest pass. And also, of course, we use separate controller and loss detection per pass. Of course, retransmissions could go over on different paths than original. So next slide, please. So back in the time, the implementation is a little challenging, especially because how our code is written that time. That time, I think, so when one packet is declared lost, so we put out the frames and reserialize to a separate packet. And then we use a struct to record the connection between the two packets. For example, one packet gets ACKed, we consider both of them gets acknowledged. So that becomes more challenging if we will retransmit packets, across paths. We need to build an even more complicated struct to record the connections between packets spreading multiple paths. But now I think the implementation is easier because we get rid of the connection between packets. We only record the content in the packet. For example, when a packet gets acknowledged, so we will report to the corresponding stream, say, hey, this bunch of stream data has been acknowledged instead of a packet. So that being said, the implementation can be very difficult, but depending on your implementation. So next slide, please. So yeah, the next one we're facing is scheduling. I think that's exactly as Roberto said. We decided to put the multipass in the connection. So that's what we are facing this challenging scheduling problem because you will never figure out a appropriate or good scheduler without knowing what the application want. For example, the application want to minimize latency. We may put packets always on the path with shortest RTT, or if the application cares about bandwidth, we will dumping packet to all available paths. Or the application cares about data usage, data plan, so we can only send packets on the Wi-Fi, maybe very important data on cellular. Or the application is very sensitive to packet loss, for example, the audio transmission. So then we may put redundancy, send the same packets over multiple paths. So without the knowledge, I don't know. So how it's so hard to develop a scheduler, which can be used for all kind of applications. And also, inside Google, so we have never have a buy-in from a customer saying, hey, I want this kind of scheduler and I want multipass because connection migration cannot meet my requirement. We have never seen that requirement. So basically what we always heard is, why don't you improve connection migration first and see if it's enough? Inside Google, we have put much effort to make connection migration work. So that's pretty good, actually. So next slide, please. So here is the lessons we learned. So because after facing these challenges and the implementation complexity and lacking of use cases, so we basically removed the code from the Chromium repository. So the lessons learned is the multipass increases code complexity. Yeah, this can be small or huge, depending upon the implementation. And scheduling is hard and depends on the use case. So if you are not working closely with application, you are likely to fail. And also, most use case only need connection migration. I think the good example is Android Google Search app. So we deploy connection migration there, and so they're happy and they're not asking for multipass. I think that's it. Any questions?
Yes, we have Spencer in the queue first. I'd like to remind people that we do have a lot of presentations today, so if they could keep comments or questions as short as possible, that would be appreciated. Please go ahead, Spencer.
I would I could reasonably ask if you think that you're saying connection migration works well enough so you don't have to, you know, thinking about multipath now might make sense if multipath makes sense where it didn't previously. But I think I'm also hearing you say what Roberto was saying about the more you know about what you're doing, you know, the more you know about what you're doing with multipath, the better job you can do rather than being a general purpose transport. Thank you.
Yeah, totally. I mean, that's kind of, so basically my understanding is we really need a, killing use case saying, hey, connection migration does not meet our requirement. We really want to use multipath, and they will closely work with us for developing a scheduler which meets their requirement. So to my experience, that never happens inside of Google. So that's why we decided not to go for multipath in Chromium.
Thank you. Ryan, next.
Fan, good to see you again. Just a quick question. Do you think the new architecture for retransmissions being in the stream instead of in the packets, do you think that would simplify the implementation to the point that it would be straightforward, or do you think it would still be huge?
Hey, Ryan, good to see you. Yeah, so totally. I think that will simplify the implementation a lot because, you know, we only record the stream data, so there's completely no connection between packets spanning multiple paths. So we exactly know, so the stream has no idea, you know, I send data to which path, to which packet number. It does not care. It only cares is, hey, this stream data has been acknowledged, I can remove it, or this stream data is lost, I will retransmit it. So the implementation should be much, much easier. Thank you, Ryan.
Thanks, Dan.
And next we have Igor.
Hey, so I heard a lot that you were talking to many clients at Google, so Google Search, Google other client applications. I wonder if you had any conversations with server people, if they were ever interested in connection migration or multipath on the server side. Like, for example, YouTube, I'm just guessing, right? I mean, some connection comes to one server, but the object is really in a different one. We want to migrate to the one that has it. Any conversations like that?
Yeah, we did have. So actually, I'm working on the server side in the QUIC team. So I think we have previously a use case we think about is exactly said, hey, the server will send out the preferred address after, you know, finish the handshake, saying, hey, client, you can talk to me to this preferred address. And then at the time, the client basically have two addresses to talk about this kind of multipath, but it's still talk to the same server. But anyway, but that, to my knowledge, that does not work greatly with our infrastructure. So that's why we gave up on that idea. But put on hold, we can totally revisit later. So. Does that answer your question?
Yeah, thank you.
Thank you.
Okay, and the queue is empty for this presentation.
Cool, thank you.
Thank you.
I'm trying to set up Christoph. Who is next? All right, Christoph, go ahead. You have an interesting slide format.
Can you hear me?
Yes.
Okay, perfect. WebEx shows me as still on mute. Are you bringing up the slides? I can't see them at the moment.
I think I'm showing them.
Yes, we can see
okay,
them.
no.
Okay,
Okay, great. I think some
the next slide.
someone said yes. Okay. So hello, I'm Christoph from Apple, and yeah, I have been working on multipath transports for a long time. So I'm going to show a little bit about the use cases we have here at Apple. Next slide. So our first use case that we have for now 7 years. It's Siri that is using multipath TCP. With Siri, we are pursuing certain goals with our use of multipath. First of all, Siri is a very latency sensitive application, right? whenever the user is talking to Siri, he wants to get the response as quick as possible. So the first goal is, of course, to minimize latency as much as possible to get the best user experience, especially in the high percentiles. And secondly, of course, we also want to reduce network errors. What is tricky with Siri is that it is building up state on the server as the user is speaking. So it is a connection that is hard to recover, right? When the connection is lost, there's basically the only way to recover it is by sending all the data yet again. So that means that we try very hard to reduce network errors with Siri because it's so costly to reestablish a TCP connection. The environment in which Siri is running is thin bidirectional stream. So that means the application is sending small amounts of data in a regular, very short time frame. Let's say, for example, 100 bytes every 20 milliseconds, for example. And the server keeps on responding. So it's very interactive traffic. It's not a bulk data transfer. And finally, Siri is also often used in mobile environments where people are walking out of the home. So that the traditional Wi-Fi fading away scenario is very frequent because people use it when they walk out of their home and say, hey, Siri, turn off my lights or whatever, right? Next slide. So this is the setting where we are in for Siri. Next slide. The way we use multipath is, first of all, when we create a Siri connection, we establish immediately the TCP subflows on both Wi-Fi and cell. So even if Wi-Fi is in a very good state, we immediately are basically warming up the cellular link as well. This enables us to basically switch from Wi-Fi to cell without having to go through a TCP handshake, right? We can immediately start sending and also start receiving, of course, data on the cellular link. And it also primes us with an initial RTT measurement. So that way we know at least we have the Wi-Fi link quality, a certain RTT, and we also have an RTT measurement for the cellular link. So we have then those two paths that are ready. And then we start scheduling traffic into what we call the interactive mode. So there's one note that I want to make is we published the multipath transport APIs a few years back in different scheduling modes that we, from our experience, are most useful to the applications. We have handover mode and interactive mode and the aggregation mode. And so Siri is using the interactive mode because it's a thin stream, a lot of data, but very latency sensitive, okay? So when we're sending, we are continuously evaluating the path characteristics. We are looking at the RTT and packet loss. And for every single packet that we are transmitting, we decide what is the most optimal path on that particular moment in time. And the best path is basically RTT based. We choose the one with the lowest RTT. Now, if, for example, retransmissions are happening on one path, we then schedule traffic on the other path to basically quickly overcome the delay that is introduced by a retransmission, right? Because the retransmission needs to be, it can be blocking the congestion window. And so what can happen is basically, for example, if you have—
Christopher, I think you need to speed up a little bit. Sorry.
Yeah, okay, I'll speed up. So then, next slide. Okay, so what are the quick requirements for Siri? It is continuous measurement of path quality to know what is happening, and the ability to switch between paths in a sub-RTT time frame. For example, if I'm getting packet loss on Wi-Fi, the next packet will not be sent on Wi-Fi, but it will be sent on cellular, just because I want to avoid the latency that is introduced by the retransmission. And also another point is, yes, the wireless and the cellular characteristics can change in very short time frames. So it is important that we are able to switch in sub-RTT time frames from one path to the other. Next slide. Apple Music. So the goal with Apple Music is that we try to reduce the playback stalls. And we also, if we still stall, we try to reduce the duration of the stall. The environment that we have is we have a bulk data transfer where we are transmitting the entire song to the device in one bulk transfer. And we also have a playback buffer that hides actually most networking issues. Next slide. So what we are trying to do here, because music can transmit very large amount of data, right? We try to minimize cellular data usage as much as possible. That's the ultimate goal. And so how we do it is by we avoid cellular data at all costs, only when we are getting close to having a problem in the music streaming. And that's when we then bring up the cellular link, and then because we are very close to basically having a music stall, that's when we try transmitting data on both paths as fast as possible, because we want to avoid this music stall from happening. So here what we do is we do actually resource pooling to aggregate both paths. Next slide. So the QUIC requirements here are basically is the resource pooling requirement, because we want to send on both paths. And the reason for that is because we want to really minimize cellular data usage to avoid causing bill shocks for the clients. And those are Apple's use cases. I'm open to questions now.
Okay, we're a little bit over time, so if people could keep this brief, I'm going to cut the queue in a few seconds, so get in if you want to. We'll start with David, please.
Yes, David Skenazy, Google. Hi, Christoph. Thanks for the presentation. I think it's really great that you split things out in terms of, okay, here are the things that Apple cares about for these services, and requirements on QUIC. My question for you on like seeing most of your requirements on QUIC, they seem to be already covered by QUIC and connection migration. Do you have an idea of what things are actually require multipath? I know like for Apple Music, if you're doing bonding and sending on both, but I think that's the only one I saw.
Well, for the first one, what we do is, and I'm not sure if that's really possible with QUIC migration, is switching paths at a sub-RTT timescale, right?
Yes. So the trick is you need to like validate both paths. Similar to MPTCP, you'd call that establishing the subflows. But then once you've done that, you can like migrate very often. There's nothing preventing you from doing that. With one requirement is on it has to be today. It has to be decided. The client is the one migrating, so it has to be client initiated. But from my understanding of the Apple stack, that's what you prefer because the client knows the cost of the interfaces and all that better than the server does.
So one thing to say is switching paths at sub-RTT timeframes, right? If there's a 100 millisecond RTT and I switch the path every millisecond, that is basically resource pooling. So I'm not sure that if QUIC migration is able to do this, right? Because we will need at each time we switch, we need to switch the congestion control. I know that Christian has a draft where he says it's possible to do that, but
I'd like to punt that part of the discussion to the general discussion, because so the point was clarification on the presentation, and now we're doing clarification on QUIC, which was, I think other use cases will have these questions, can QUIC do this, right? So I think that would be best handled at the end. Thank you.
All right, my apologies. Thanks for the answer, Christoph.
Yep.
Okay, next up, Matt Joris.
Hi, Matt Joris, Facebook. Echoing also, I thought it was a good presentation. My question is pretty brief. You mentioned Apple Music. Does Apple have any experience doing non-music streaming, like video streaming? Because I ask because I do think the considerations are a bit different. Because music data can be very, very small, whereas even a modestly sized video will be larger than an entire song. And I think it kind of exacerbates a lot of the policy problems that I see. Like, you said you want to minimize cellular data use, and I think that's a noble goal, but I think that's somewhat easier to do when you're the phone provider as opposed to another application. So like for us, for example, if you're using a Facebook app, communicating the fact that we're going to do this thing where we use both interfaces, I think is difficult, especially for things like video. So I was just curious if you'd done things that were more data intensive than music and Siri.
Yeah, we haven't investigated. I mean, we looked at video. One problem with video, especially with adaptive bit rates, is that It is estimating the bit rate that it is getting, and so it could get confused by multipath. That's why we didn't go down that road at the time, also because we didn't have the time. In terms of data usage, that is always a problem, and the system usually imposes restrictions on that. At least for our multipath use cases, we have Wi-Fi assist that is limiting the cellular data usage of each application when Wi-Fi is available. And so that's like our system that is like the police that mandates, okay, you are allowed to use cellular data now, and you can only use 100 megabytes, and you're not going to be able to use more.
Okay, let's move on quickly then. Thank you. Jana, please.
Hi, Jana Iyengar. Thanks, Christoph. Same thing. It's really useful to see where these things are being used, and it's good to see you as always. I have two questions. One on the Siri, you mentioned switching back and forth between multiple parts at the sub-RTT time scales. Do you do that more than once per RTT? I would imagine not, because you would have to switch, wait for feedback, and then switch again. So I would imagine that you're probably switching at the highest rate you would be switching is once per RTT. Is that? I have two questions, but that's the first one.
Yeah. The highest rate is once per RTT of the lowest RTT subflow. Yeah.
Of course, that makes sense.
Go ahead. Yeah.
So I think that just to echo something that David said earlier, it does put a cap on how we think about resource pooling here, because you're not switching at millisecond times. You're not switching at packet time scales. The second question was on music, and I'm echoing what Martin asked on the chat channel. When you do resource pool, are you sending the same data over multiple paths, or are you just like trying to utilize both paths, bandwidth maximizing for that short?
Yeah, we are maximizing the bandwidth. We use the scheduler that is defined in one of the drafts that we submitted to ICCRG. Which is basically, it's a scheduler designed to optimize throughput. Yeah.
Okay. Thank you.
Okay, and we'll move on to Olivier for the last question on this.
Yes, thank you for the presentation.
You're very soft, Olivier.
Okay, so thank you for the presentation. Do you hear me?
Still very far away.
Then let's move to the next one. I will.
Okay, thank you.
Hello, Lars. I think we need to share from our side.
You can. I can also run it from here if you prefer.
Let me share. Okay.
Okay.
Can everybody see now? So Yemei and I'm Yunfei. Yemei and I will present for Alibaba use cases.
Go ahead.
Let's start. Hi everyone, I'm Yemei from Alibaba. My colleague Yunfei and I will introduce the use cases in Alibaba's ecosystems. Next page, please. These use cases include new retail e-commerce use cases and the mobility use cases. Then we will talk about some 5G and beyond. There will be a summary of the requirements for the path management and the package scheduler in Multipath QUIC, and a demo video of our deployed version of Multipath QUIC in Taobao. Next, please. The first use case in Alibaba is the Taobao mobile application. Taobao is the most popular online shopping application in China, and instead of just showing a picture, it uses short-form videos to display the product information. Today, Taobao already uses QUIC and HTTP3 for video downloading. Reducing startup delay and stalling time is critical, so we employ Multipath QUIC, which uses both Wi-Fi and LTE at the same time. The main purpose is to accelerate video downloading and reduce stalling and rebuffering. With better quality of experience, our customers are more willing to buy the products. In the meantime, we use Multipath QUIC to accelerate the video uploading, so the video creators and bloggers are more willing to upload their new works on our platform and will attract more users. Next, please. The second use case is Taobao Live. It's like Amazon Live. More and more streamers and internet celebrities stream outdoors. In picture 2, a streamer stream outdoor in his orchard. He's showing a jujube just picked from the tree and telling the customers how delicious the jujube tastes. The problem is that sometimes the uplink is very slow. So we want to help the streamers to stream outdoors with multipass QUIC to use more bandwidth through 2 disjoint network links. The streamers can use a mobile phone with LTE from carrier 1 and use a mobile Wi-Fi hotspot to connect to carrier 2 in the same time.
Another strong need to deploy multipass is a high mobility application scenario. So one notable example is a high-speed rail in China. In the year 2019, there are over 2 billion passenger railway journeys. However, because the train is moving at a speed over 300 kilometers per hour, handovers between base stations happen every 13 seconds. So even though the train is equipped with Wi-Fi, today the internet experience is far from satisfactory. And with MP QUIC, a user can use his or her cellular and the train's Wi-Fi at the same time. And so they can also connect to multiple mobile carriers, which helps the mobility issue. And the apps from Ali ecosystem that can benefit from doing so are Taobao and Alipay for online shopping, DingTalk for business collaboration and communication, and Youku for entertainment for customers who want to use these apps on the road. And the last thing we want to talk about is 5G coverage. So China right now is rolling out 5G sub-6 gigahertz, but the 5G operates on higher frequency, so the percentage of 5G NSA coverage hosts is larger compared to 4G. On the right side shows a measurement study where the pink color areas indicate the spots 5G signals are too weak to communicate. And in comparison, the 5G coverage host is 8% versus 1.7% in 4G when the base station have the same density. So MP QUIC becomes a solution to address this issue with possible simple in-app customization. And in summary, we present some of the MP use cases right now Alibaba has major interest in, and 2 things we want to emphasize in this presentation. First, in our implementation, we build multipass QUIC over bidirectional subconnection concept, and this makes things simple and enable the use of most QUIC transport design. And second, we employ a dynamic scheduling strategy with feedback to optimize performance. And also want to echo Fan Yang just from Google just said. So scheduling, we found that is really important because in order to utilize MP, we need to understand what the application wants. And so in our design, we use the dynamic scheduling strategy, which allows the client and server interaction to support application awareness. And before conclusion, here's a demo where we have integrated the MP QUIC into Taobao and the Ali Cloud CDN, which is the largest shopping app in China. And we contrast the MP QUIC on the left with the single pass QUIC on the right. As is shown, MP QUIC is effective in offering much smaller startup delay and much less stalling. With that, I would like to conclude the talk, and we are happy to take questions.
Thank you. You talked about high-speed trains, and that was a high-speed talk. Thank you. I don't see anyone in the queue. Does anyone want to jump in? While we have the opportunity.
I have a quick clarification question. When you say MP QUIC, you actually mean drafted conic, right? You using that, or are you using MP QUIC as a short for multipath QUIC?
I use MP QUIC as a short for multipath QUIC.
Okay, thank you. I was going to ask the same because some other slides also have MP QUIC on it, and often that is used as a acronym for multipath QUIC, but it's also the name of one particular proposal, which makes it a little bit confusing. Thank you. That was a good talk.
We have Jana in the queue now.
Jana Iyengar, thanks for that. Thanks for that talk. I'm trying to. There are a number of things that I'm missing here, so maybe you could help me understand this. I didn't fully grok. So these are all using some form of multipath QUIC, which you clarified that is not actually the draft that we have out there. But what's the server, what's the client, and are you using this in production? Those are 3 questions just about the setup that you have here. have you?
Let them answer the 3 questions first, Jana.
Fair enough.
Oh, okay, I can answer that one by one. So the first question is, okay, so about the deployment, right? So the first thing is we deploy the protocol in both our Ali Cloud CDN and also the client, right? The client are the apps such as the Taobao, right? It's like Amazon is an online shopping app, and this is how the deployment is made. This is the first question. Oh, so what are the next question?
Are you using this in production right now? Are users actually using this, or was this a demo?
So we have a small scale deployment, and we are trying to experimenting with the MP QUIC right now. So this is already a production. Yeah, but we are experimenting. So right now so some of the users can get access to MP QUIC, but not all of them.
Sure. So have you experimented with connection migration in QUIC?
Yes, we have experimented with connection migration. So one issue we found that is, so sometimes, let's say, right, so the connection is not break. The connection is just the bandwidth is not enough. For example, for the Taobao Live streaming case, right? So we have many internet celebrity who lives on streaming, and they want to do streaming outdoors. And what they find out is they care a lot about performance because they make money on that, right? So they want to make sure that their internet is very stable. And so that's why they want to have multiple uplink, especially in some area, in rural area in China, right, where the uplink interconnectivity is not very good. So if we deploy MP QUIC, this gives them opportunity to double their bandwidth. So that's one use cases. And the other use cases is about the high-speed train, right? Because I think the LTE and 4G, they already have done a lot of job in doing the handover, right? So, but the thing is, the high-speed train is travel so fast. So when you have handover every like 10 seconds, right? It's still difficult to make sure that the internet connectivity is good. And because the high-speed train, right now there is a high-speed train Wi-Fi, and so the Wi-Fi works like this. It has a hotspot inside the carriage. It also has an antenna outside the train, which can connect to the cellular. But the thing is, there are so many people sharing the same Wi-Fi in the same carriage. So everyone gets a very limited bandwidth. So what they want to do is they say, okay, I also have the cellular, so why can I use both the Wi-Fi and my own cellular at the same time? So, and then our design is made to for the need of these customers.
We gotta speed up a little bit with the questions and the answers, please, guys.
No, I would love to see more details on what actually you're doing here, because you said you're not doing the draft, but you're doing your own thing. And I'd be very much curious to understand exactly what you're doing. So if you were able to publish a draft or something like that, that'd be super useful.
Oh, okay. So yeah, the draft link is here. So you can see. So we attach the draft link in the slide. So if you're interested, you can take a look.
All right, thank you.
And Jana, there's an QUIC channel on Slack, which is their implementation, which I think they're planning to open source at some point this year.
Thanks for that.
Okay, we have David left in the queue. If you could keep it brief, please, David.
Yes, very quick. Thank you for the presentation. 2 short questions. First one, was this MP QUIC end-to-end from the client to server, or was it with a proxy involved?
It's end-to-end, MP QUIC end-to-end.
Thank you. Second question, you mentioned like users care about performance. I totally agree. What specifically do you mean? You mentioned bandwidth. So I see you've measured that and you've shown results. Did you also measure latency and things like that?
Yes, we have this latency measurement, but it's not shown in the slides.
But it's not making it worse, is I guess my question.
Yes. So I think one thing I want to emphasize here is, so in different area, right, the latency can vary. So especially when you use Wi-Fi and LTE, it probably goes through different ISP, right? So and based on the measurement, and sometimes you need to adjust scheduling policies. That's why I think the design a good scheduler for MP-QUIC is the most important thing.
Oh, absolutely agree. Because for some use cases, all you care about is throughput. In that case, that's great. But I think for a lot of them, latency is important. So that's why I just was wondering what kind of numbers you had. But awesome, thank you.
Okay, thank you. Next is Jörg. I'll run it from here if that's okay, and you tell me next slide.
Yeah, sure, fine. Yeah, hello everyone. My name is Jörg Deutschmann. We have a use case which improves the situation for users which suffer from poor internet connectivity. The idea is basically to combine a slower terrestrial link with a geostationary satellite one. So the terrestrial link offers low latency while the satellite one offers high data rates. The architecture which we have at the moment relies on TCP proxies, which has some advantages for us. First, multipath is limited to the access network, so between both PEPs we have more or less perfect knowledge of both link characteristics. Second, the links between the PEPs are provisioned statically, and like so often, the scheduling is the difficult part. With split TCP, the PEPs can aggregate data from TCP senders, which we then use as scheduling decision. We also switch at sub-RTT levels, but given that the RTT of the satellite link is something like 600 milliseconds, that's not too surprising. And of course, we also allow bandwidth aggregation. There are some performance evaluation results in the appendix of these slides, but there is no need to discuss them here and now, I guess. So next slide. Now, with QUIC, there are no transparent TCP proxies anymore, so we thought about how we could realize our use case end-to-end with QUIC. We came up with the following requirements. First, and probably the most important one, before the satellite link can be utilized in a multi-path scenario, it should perform well in a single-path scenario. Second, there is the need for fine-grained scheduling among both links. I don't know if connection migration would be sufficient for this. Again, scheduling for such link combination is quite difficult, even both paths are available simultaneously. It might also be good if, for example, UG frames are always sent via the terrestrial link, while stream data is split among both paths. The next point is that we would like to use the satellite links as soon as possible. So in the best case, we would set up the QUIC connection for each path with 0 RTT. Anyway, we didn't test the multipath QUIC implementation yet, so I really cannot tell how good our use case will perform in an end-to-end setup. We also thought about multipath and masked proxies, but we neither have results for this yet. From an architecture point of view, this is a hybrid access network with difficult link characteristics. So I think we will see a similar figure in the presentation about hybrid access networks. Next slide. A remark that in future there will be even more kinds of internet access links, especially low Earth satellite constellations. I think this is the motivation for multipath in general. And finally, there is a paper and an internet draft which contains some more information. So I'd be happy to receive your feedback on this use case, and that's it from my side. Thank you.
We have a question from Matt Juris.
Yeah, just to clarify, for this use case, this is essentially like a proxying tunnel use case, right? Where the end user application is not aware of the tunnel. Was that pretty much right?
Yeah, correct.
That was just my question.
Okay, in that case, we'll move on to Christian, please.
Just a clarification question about this talk of satellite proxies. Is that a deployed product or is that a research project?
Not yet. This is the outcome of a research project, and we're starting with some field tests next. And yeah, and we also have to do tests with multipath QUIC first. So we're, I guess, in a very, very early stage, unfortunately. Does this answer the question?
Yes, thank you.
Okay, we don't have any more in the queue, so I think thank you very much for the presentation, and I think we can move on and take some time back.
Yep, Olivier's next. Let's hope the audio is better. Olivier, can you try?
Yes, is it better?
It's perfect. Thank you. I'll run it from here if you like.
Yeah, that's perfect. So the idea is to inform you about the hybrid access networks use case and the requirements that this solution puts on multipass QUIC. Next slide. So the use case is that there are hybrid access routers, so hybrid CPEs that have DSL and 4G connectivity. And these are deployed in the field. And when, as a user, you have this kind of device, basically what you get usually is that you can use either DSL or 4G, and you use 4G as a backup, while the user would like to be able to use both DSL and 4G, especially in rural areas where you don't have enough connectivity, enough performance from the DSL network. Next slide. So I will discuss the MPTCP-based hybrid access networks that are deployed, and then I will look at MP-QUIC in these scenarios. Next slide. So the currently deployed solutions work with multipass TCP, and so they combine the wired access networks, which is typically DSL, with a wireless access network, which is typically LTE. And there are specifications from Broadband Forum and IETF with MPTCP. Next slide. Yes, so the solution allows end users to use regular TCP, so single pass TCP, and there is a transparent proxy on the hybrid access router that will proxy the connection so that it becomes a multipass TCP connection that goes over the DSL and the 4G network. And it goes through a specific device in a specific proxy, which is called the hybrid access gateway in the operator's networks that does the conversion between MPTCP and TCP so that it speaks TCP to the external servers. And that's similar as an architecture to the protocols that are used for ATSS in 5G that Spencer will mention later on. Next slide. So what are the benefits of multipass TCP in these hybrid access networks? The main benefit is that it provides bandwidth aggregation, which is key for the low and the medium bandwidth speed networks that exist in many countries and in many regions throughout the world. And one advantage is that the congestion control allows to automatically adjust the bandwidth to the network capacity and sense the available capacity. And the operators that have deployed this solution, usually they want to prioritize DSL over the LTE network. And so they do this using two different techniques. The first one is the path manager, which is the algorithm that decides when to create a subflow over one specific path. And so they can delay the creation of the LTE subflow if the DSL link is not fully used. And then there is an algorithm which is called the packet level scheduler that operates at the packet transmission level and that prefers the DSL path over the LTE one. Next slide. So now let's look at what MP-QUIC could do in hybrid access network and what it would bring with the requirements. I think that there would be three benefits with multipass QUIC in hybrid access networks. First is that by leveraging the datagram extension from QUIC, it's possible to provide bandwidth aggregation for non-TCP flows using MP-QUIC. The second is that MP-QUIC could be an over-the-top solution that would aggregate bandwidth for any combination of different access links, even from different ISPs, going through an hybrid gateway that would run in the cloud. And the third advantage is that, well, MP-QUIC would be implemented in user space, which would not require kernel changes in the access routers. Next slide. So what are the requirements for MP-QUIC in these kind of networks? I think the requirements are that you need to be able to learn the availability of different paths and addresses. And on mobile devices, these paths and addresses can change over time. It should be possible to start and stop using a path. It means that you need to have a path manager, which is the intelligence that decides when and how to create subflows. It must provide aggregation, so you need to be able to simultaneously send packets over the two paths, or sometimes more paths than that. In some scenarios, you want to prefer some paths over others, so you need a packet scheduler, and you need to be able to sense the performance of the different paths by using ping frames, congestion control, and other techniques so that you can you have varying capacity paths that you want to aggregate. Next slide. And the last slide is that with MP-QUIC, we could even think a solution where you don't really need a proxy on the hybrid access router. And with MP-QUIC, you could have end-to-end MP-QUIC from the client to the server, provided that there is a way for the router to tell the end host that there are multiple paths available. And one way to do that would be to use the PA multi-homing solution, which is being developed within the RTGWG working group, where basically you advertise two different IPv6 prefixes to the end host, one attached to the red network and one attached to the green network. And with that, I think I've covered what I could cover in a few minutes. Thank you.
Thank you, Olivier. We have Matt Drawers in the queue and nobody else. If you want to get in the queue, please do now. I'll be cutting it shortly. Matt, please go ahead.
So I have a hypothetical question. So if I am an end application that is already natively using QUIC, not necessarily MP-QUIC, would this sort of setup transparently to me essentially tunnel my connection over two paths without either the client or the server knowing?
So today, if you use TCP, it would be transparent for you. If you use QUIC, it's likely going over a single one of the two paths.
Right, but what if I was using QUIC with this MP-QUIC proxy? Because you said datagrams would be forwarded over both. Would that?
So then you could send the QUIC datagrams as datagrams over the two paths.
All right, that answers my question.
Thank you. We have David. Please go ahead.
Sorry, waiting for it to unmute there. David Skenazy, Google. Just to kind of build up on Matt's question, Olivier, when you send the QUIC packets over datagram frames on both, you won't have access to the QUIC packet numbers. So because of the different latencies on the different paths, you can introduce a lot of reordering, which we know, as with TCP, causes problems. Have you implemented this and measured if it causes any performance problems?
So we've done some experiments with that. So it works, and there is other works that looks at putting timestamp and other information to be able to reorder the QUIC packets or other packets at the server side, so that you can avoid resequencing if it causes problems.
I see. So you would actually artificially delay received packets to put them back in order. Interesting. I've seen that cause issues in TCP, but we haven't tried that with QUIC.
Yeah, it really depends on the implementation. So we looked 1 year ago at QUIC implementations, and they did not cope well with reordering. While TCP implementation would cope much better with reordering, at least when looking at the recent Linux TCP implementation. And I guess some QUIC implementation have evolved now, and they deal better with reordering than what they did 1 or 2 years ago. So this is changing quickly.
Thank you.
Okay, I think we're done for the questions there. Thanks again, Olivier. We can move on to the next.
All right, that's the 3GPP ATS SSS presentation, triple S. I don't know who's talking to these slides or if it's a combination, so I'll run them from here and you guys speak.
Cool, and Spencer is at least starting. Thank you, Lars. Next slide, please. So I just want to be sure and mention that this is not us being the ATS SS whisperer, and we're not wearing any 3GPP or IETF hats. We have some links here that people may find helpful, and I will go to the next slide, please. So I really want to talk not so much about ATS as ATS, but as a multipath technology, and ATSS uses only two paths, one 3GPP, one non-3GPP in their work. They get rules that assigns modes per flow. The vocabulary that they use, which I think is helpful, is steering is selecting a path, switching is selecting a different path, and splitting is using multiple paths simultaneously. So for the figure on the right, please look at what's in purple, not what's in black. Next slide, please. So what I'm talking about in my presentation is the combination of things from ATSSS and enhanced ATSSS. So there's this basically ATSSS is two different protocols. One is using MPTCP. One is using traffic aggregation without any specific protocol between the tunnel endpoints. What they've been able to achieve so far has been for non-TCP traffic has been steering and switching only. What they're trying to do in enhanced ATSSS is splitting for non-TCP traffic of any IP and Ethernet traffic, and they're also talking about support for additional EATSS modes beyond what's in ATSSS initially. Next slide, please. So this is basically just to say this is the tunneling proxying. They have proposals to do both of those. From the combination of what's in ATSSS and EATSSS, but wanted to just say basically these are the endpoints between the user equipment and the tunnel endpoint before you get to servers. When we say MP QUIC, I'm really talking about multipath QUIC. This picture is out of a 3GPP document, so we didn't change the labels, but don't pay a lot of attention to that detail. Next slide, please. Just a minute. So just to mention the campus enterprise use case, this is very much the similar to the hybrid access use case that Olivier presented very capably, and just with some additional details on benefits for the user and for the access provider. Next slide, please. So the ATSSS modes, these are already deployed. Active standby and smallest delay based on RTT, and load balancing. So you say basically I want 30% of my traffic to go this way and 70% of the traffic to go that way, and priority based. Some of these can work pretty well, I think, with my connection migration and QUIC version 1. Some of them do require some multipath capability, and priority is really interesting because you're basically moving from one path to another based on congestion being encountered, but the way it works in the priority-based mode is that you're still only using one path, so that if you wanted to do both paths after you encounter a congestion, you need a multipath capability also. Next slide, please. I said there are some additional steering modes that are in EATSSS. these include things that are under discussion, like changing the access split weights dynamically, so that basically, what's in ATSSS is only using you only change the split if you have a path that goes down. So this is being able to change access splitting dynamically, forwarding on both accesses when necessary to provide redundancy. This one I really kind of dig. Forwarding on both accesses if the RTT difference between those two paths is below a threshold, so that basically they become functionally equivalent to each other. But if they're not, then you go on the one with the shortest RTT. And kind of a catch-all, the UE making decisions about uplink access and so on based on lots of things. None of these, I think, can be supported using only migration that's as defined in QUIC version 1. So my point of showing that slide is basically to say that where we seem to be headed is a lot more dynamic use of multiple paths. Next slide, please. So, like I said, what we're trying to do is support traffic splitting across multiple accesses for any IP or Ethernet traffic within order delivery. We really hope we can do that with multipath QUIC because it's building on the synergies of the QUIC stack. We know that the UEs are going to already have a QUIC stack. So if we don't do something with QUIC, we're going to be doing it some other way. Like I say, what we're really shooting for is simultaneous use of multiple paths with in-order delivery within a stream split over multiple paths. I think that's my last slide. Questions?
Rapidly moving, we will go to Martin Duke first.
Hi, Martin.
Hi, Spencer. Thanks for this. I maybe I'm not following, but I think what you're showing us is customer QUIC packets encapsulated inside datagram frames of an outer QUIC connection. Is that accurate?
I think that's going to be true. I should mention the people that are looking at this right now are at the architecture level, and that's going to be stage 2 level, and that's going to be something that the stage 3 guys are actually going to be discussing in more detail.
So I wonder why. So if that is in fact the use case, like why not just use like a layer 3 solution and just switch QUIC packets over multiple paths rather than have another layer of transport?
So if you back up to maybe the third slide. Yeah. So basically, the picture that's here is what's deployed now, which is like I say, one of the things is multipath TCP, and the other is a low layer ATSS LL low layer solution now, something like that. So I think they're trying to basically reason from what they're working with now to where they should be going. I think it's fair for me to say that this work is probably more probably early in the process that you're going to get from most SDOs coming into the IETF, but 3GPP really wanted to work closely with the IETF so that they weren't trying to duplicate things that the IETF was going to be doing. So that's what you just asked is a very interesting question. Thank you.
Can I just jump in for a second here, maybe to clarify this a little bit more? So what you described is actually ATSSS lower layer. So there's no additional protocol. And this ATSSS lower layer mode is only supporting steering and switching. What they don't want to do is really use both of the paths simultaneously, because that would introduce a lot of reordering, and that can have negative effects, especially as you don't know. Like you want to realize this for all kind of IP and Ethernet traffic, so you don't know what the traffic above is. So they try to avoid reordering. That's like the main point here.
Thank you, Miriam.
Okay. we're very short of time, so I'm going to move on to Richard to ask the next question, but please keep questions and answers.
Hi, Richard.
Oh, hello, good evening. Yeah, Richard Bradbury, BBC here. I just wanted, do you happen to know what the anticipated timescale for this AT-SSS work is? Is it a release 17 3GPP item? Do they want to get it done and dusted in the next 18 months?
That is the current plan of record in 3GPP.
Okay, and do you think IETF can rise to that challenge?
I'm here.
Sorry, I should have said my name. I'm Mia Kulevin. Let me jump in again. So so this is under discussion currently. There are different solutions proposed for release 17. Due to the whole crisis, there's also discussion about extending the deadlines for release 17 by 6 months. And so I think what they need is really, they need some kind of stable or adopted working group draft. They don't need to have all the details figured out because there are no dependencies on the actual details of how this is realized, as long as they know that there will be some MP QUIC support at some point.
Okay, so they're happy to not have RFCs, for example.
That's there are many specifications in 3GPP where there's not an RFC yet. There is like a lot of discussion in 3GPP right now how mature this is, and it's definitely not mature enough, as we don't know that the QUIC working group will work on it. But as soon as there's a working group document, there could be like a level where they could just move on.
Okay, cool, thanks.
I think it's if I could just how long has it been?
We gotta get to the questions,
Sure,
guys. We
sure,
are
sure.
already quite late. Sorry.
Sure, that's fine.
Okay, let's move on to David, please.
Hi, David.
Thank you. It's me again, David Skenazy, Google. So Spencer, thanks all for the presentation, especially the terminology. That helped a lot because it's very different from what I'm personally used to. So that was great. You described benefits of this project in terms of like network, like I can use both paths, and I think that's cool. Sorry, great. I have a police car outside. But the what I'm kind of having a hard time understanding is what is the benefit to the user in your mind?
So I think the benefit. So this is the provider view of what we're talking about, and I think the use case, many of the other use case presentations have been about the use cases that the providers are expecting to have running over their networks. Does that make sense? So if they're going to be doing music over the network, it would that's kind of what the 3GPP guys are expecting is going to happen on their networks. Does that help?
Well, I'm not sure I understood. Let me rephrase what you just said to make sure I understood. It sounds like you're saying there's no user benefit, but this is good for the provider. Is that what you're saying?
No, I'm sorry. I'm saying I think that this is what I'm talking about is the provider view, which may assume, which I think in the other use case presentations even did assume that there were benefits for both the users and the providers.
So I understand that we're assuming that there are benefits, but what are those benefits? If we're going to take on work in the IETF, I think it would be good to think about why we're doing it, right?
Yes, I think mostly what I'm saying. I think mostly what I'm saying is that those discussions happened in 3GPP a long time ago.
Okay, and we don't know the outcome of those conversations?
They happened before Spencer got there.
Okay, no worries. If you don't know the answer, that's fine. Sorry, I didn't mean to put you on the spot.
Yeah.
Let me jump in for a second again. So I think in the setup you have here, the benefit you get is that you actually have a direct interface between the UE and the network, as well as the proxy endpoint, which is directly in the network, has knowledge about what's going on in the network. So you can actually provide some guidance to the UE just to give more information about which path to use.
Maria, if I may, I'm not talking about anything in the network. I'm talking about as a user who is using a cell phone, well, a smartphone, what benefit do I get?
Yes, so you're using a smartphone, you have two passes available. If the server provides multipass support, you could as well do this end-to-end, right? But then you don't get any information from the network about what the network conditions are currently and which pass is the better one to use for you right now in your current situation. And that's the benefit you get here.
Okay, I'm sorry, maybe I'm doing a very poor job of explaining myself. As an end user, I'm not talking about me as someone who works in networking standards. I'm talking about an end user who wants to visit a web page, watch a video, live stream, whatever. What is the benefit to the end user, like to someone that is non-technical?
So I think you're asking a question about how telcos, for example, put in the tariffs. And there is, for example, the idea that if you have ATSSS and the network can tell you to offload your traffic to a managed network, to a managed Wi-Fi network as soon as you can, then you get like unlimited data or whatever. That might be a subscription that you want to choose, and that requires this kind of function support in the network. But that's really not the technical question here.
So yeah, the answer I'm getting is that this is useful for network operators and they're interested in this. And that's a reasonable reason to do things, don't get me wrong. But we're saying that there's no benefit to the user. Okay, thank you.
So sorry, may Hanno step in. So the benefits
guys, we gotta move on. This is a general discussion. We're already eaten half of our general discussion time, and Mike wins the prize for the last agenda bash, which happened, and he promised he can do this. So there's one more use case that wasn't on the agenda when we started, which is here now. So he has one slide in 1 minute, and there's not going to be any questions, Mike. So you better nail this one.
Okay, I'll do my best. So the very short version is that we have been talking about a scenario where clients make requests. We have lots of different instances that may or may not be the same location. The instance that gets the client's connection might not have all the resources that the client's requesting. And so right now that instance has to go fetch those resources from other nodes that do have a copy. And it would be nice if it were possible for those other nodes to send the content directly back to the client, which basically means a distributed server instance. That's something that we can do with QUIC right now, potentially. You would have to have some coordination between the instances, give it a range of packet numbers that it can use, but it produces a lot of apparent reordering because they aren't able to coordinate sending packet numbers in the right sequence. If you have separate packet number spaces and multipath, you could probably make this look a lot cleaner, but it would be nice if certain things about the path can happen on each path. The client would still see it as a distributed server with multiple IP addresses. And I'm slightly over my minute, so there you go.
So Mike, one disclosure as a third party here is that I believe that Nokia holds IPR on this idea, at least for multipath TCP. And I know this because it's my patent.
Okay, thank you for letting us know.
Right, so we didn't give you questions. So let's get to the general discussion. And again, the point of this session was to understand what some of these different use cases.
You're on mute, Lars.
Yeah, so sorry, it's been a long day. So the purpose of the meeting was to figure out what these use cases are in a bit more detail and what requirements they would have for functionality that's maybe missing in QUIC version 1. And I think this was helpful. There was a lot to chew on and it was a little bit all over the place, but I would specifically maybe use this remaining 20 minutes to see what use cases, if any, I think we've seen this in the beginning, could maybe already be supported with what version 1 offers, specifically migration to preferred address. And then a second part of the discussion would be whether there are other pieces of functionality that we might want to consider adding to version 1 in some form that would maybe support many, hopefully, of these other use cases. And I'm guessing there's a queue building that Lucas is going to run again. And please keep it short. We only have 20 minutes left.
Martin Duke, step up.
Yes, speaking as an individual, Martin Duke, F5. So I think migration is very, very close to solving many of these use cases. But one thing that I'm seeing is that there's a lot of hot switching back and forth between the ideal path. And the current migration assumption is that once you migrate off a path, you can more or less throw it away. So that drives us. So I think like there's only a small amount of protocol you need to resolve that. I think Christian's draft actually has a lot of the pieces you need. The other thing I'd say is that we saw a lot of different use cases, and those use cases implied a whole bunch of different schedulers. So this further solidifies a conviction that we should not tackle that problem, and we should build a little protocol to the protocol necessary to enable experimentation in all of these areas. Thanks.
Thank you. Next, we'll go to Christian.
Thank you. This is Christian Wittmer. Yes, I mean, the one thing I learned today, and the great idea is the point that Roberto made, and also that was reinforced by Christopher, that basically scheduling belongs in the application. I mean, if you have any kind of complex scheduling, it has to be done by the application. And it's silly to believe that you can build machinery embedded deeply inside the stack that does better than the application. So I think that there is a need for probably a simple kind of a hot standby kind of scenario in which you have two lines and you send arbitrary traffic on one or the other based on a very simple algorithm. But anything more complex, I think that Roberto is right. It'd be better to have several connections that can be coordinated with a lightweight code management system so that, hey, I do that connection and then I do another connection to exactly the same server. And then the application sees those connections and does its scaling of them however it sees fit. And that seems like a much better plan than trying to build a ton of complexity inside the QUIC stack.
Thank you. Next up, Ian.
Yeah, thanks. I was curious to hear a little bit more from QUIC since they do something very similar to this on the direct server return stuff. But I tend to think that there are two states of the world, one in which only one server is sending like a video playback where the video is all on one server, in which case you don't need to deal with the rearing problem in a special way, and things largely just work, and the existing solution is pretty sensible, and you can just do DSR. And then the other state of the world where the ACK frequency draft solves your problem by just allowing you to control acknowledgements and ignore reordering entirely. And I think that's probably what QUIC is doing, but I'd like confirmation of that, which is another way of saying I think we might have drafts that already exist that completely solve the direct server return sort of problem that was just presented, which is not to say we have solved all the other problems, but yeah.
Thank you. Next up, Martin Tom.
I was just typing up my response. I think this is an interesting discussion. There's a bunch of things here that are interesting. Christian pointed something out that I think I was about to say as well, is that there's interesting interactions between the application and the thing. And QUIC perhaps is a little bit less susceptible to the sorts of opacity problems that result from embedding these sorts of capabilities deep in the network or deep in the OS where you don't have a whole lot of visibility into what's going on. But I want to up-level a little bit. The question that I would prefer us ask is, what should the QUIC working group be working on next? Rather than should we be doing multipath? Because I think that I've been convinced, at least from this, that there is some value in some cases in having multipath at some point in the future. The problem, though, is that I don't think that we'll get the sort of synergies, to use the point that Spencer brought up, the synergies with the deployed protocol if we allow the protocol to fork. And I don't see that the people who are deploying QUIC actively right now being interested in doing some multipath stuff.
Thank you, Martin. Next, Eric.
I think we've seen a couple of things just now. One of them is we knew going in that migration doesn't cover bandwidth aggregation. That was very deliberate, and it was kind of intentionally set up such that that was minimally prohibited, with the idea that somebody could write a very minimal extension that would kind of re-enable that and turn those on for folks who wanted to experiment with it without signing everybody else up who's doing QUIC to support all of those mechanisms. Because I think one of the problems that we've seen is trying to deploy multipath is that the policy around money is kind of more problematic than many of the technology questions around scheduling and everything else. And we have seen a number of cases here that are a little different than the usual way people think about that. Specifically, if you're already on an expensive interface and have a cheaper interface that's maybe not good enough to support all of your traffic, being able to offload some of it actually saves you money, whereas most of the other multipath cases generally end up costing you money and therefore end up being heavily restricted to the point that they may not help. So that was new for me. So I just wanted to say thank you to the folks who are presenting that. The last thing here, specifically to what MT was just saying, is I think Roberto's point about applications needing to be able to express their scheduling needs is really, really good. And so either applications need to be able to tell the system, hey, here are my scheduling needs, and the system can deal with the policy, or the system needs to be able to hand the application, this is what the policy is, you know your scheduling needs, please do the right thing. But it seems like a lot of those questions aren't, let's get the QUIC working group to do a bunch of protocol design to make stuff work. A lot of those questions are, how do we deal with policy and platform design, not how do we build a protocol that we can actually deploy.
Thank you. Next up, the MAP RG research group.
Yeah, hi, this is Mia Kulevin. Yeah, I wanted to just react to Robertus because he was just like, you know, stating this out and then it's gone by the time we didn't have a chance to comment. And I really disagree with his point of view. I don't think it's an accident to have it in the transport layer. Having multipath control in the transport layer enables a lot of optimizations that you can't do in the application. You can retransmit your packets that got lost on one path on the other path and so on. So that's where the benefit comes from. I agree that like for scheduling, you need some kind of input from the application. But what we've seen so far, I mean, there's a lot of room for research and finding new fancy schedulers. But what we've seen so far is that you usually have a handful of schedulers which are optimized for specific scenarios. And the application can just choose between those schedulers. So it's a very simple interface that we need, but that's it. So I don't think that's the challenge here. But the benefits from integrating this into the transport layer are much higher. And I think this is a general feature that especially smaller applications that don't put like all the effort in developing their own stack and so on can benefit from in future if it's just there as a general feature.
Thank you. Next up, Yun Fei.
I want to share more of our experience with the multi-mode. We definitely agree that we should keep things simple. Right. So and on the other side, I think based on our experience, the current QUIC, if user truly want to or a customer truly want to use multipath, is still need some additional capability. So I would like to I think the best way is to review all the proposal and to see if there is a simple way for us to enable this capability. And I definitely agree that also a lot of the policy and a lot of especially for the scheduler, it needs to be decided by the scheduler. And also one comment on the money side. So we do see so one issue, right? So coming from multipath QUIC is that for some customer, the traffic charges for cellular and Wi-Fi they're different. And so I think one way is at least for us is to collaborate with some mobile carriers, and so that we know that when the customer are using our app, and they can get free charge for both Wi-Fi and LTE, and so that's how we tackle this problem.
Thank you. Next up, Jana. Just to remind people, we have 9 minutes left of the session. I would guess Lars wants some time to wrap up at the end, so please keep it. Oh, good. So I got 8 minutes.
Jana Iyengar, can you hear me? All right. Just a few quick points. One, on the policy and scheduling thing, I think Eric said it really well. There's the use of multiple paths is fundamentally something that is tied very closely to the network and to the application. There's just no two ways about it. You either make the API really thin between the application and the transport, or you make the application decide. That's a question of where you draw the line of the API and what really you expose through the API. But fundamentally, multipath is tied deeply to its use case. This is something that I really was hoping that people would bring out more during the presentations, but I feel like it didn't come through very much. I think I love some presentations which did make it more explicit, but the application is super critical in terms of figuring out exactly what multipath even means. Another way of saying this is that the charter, as we have it right now in QUIC, we've effectively done multipath. Connection migration is multipath. For people who don't believe that, I'm happy to have a conversation separately. Use of multiple paths is what multipath is. And so arguably connection migration is already doing that. So the question for me still in a number of cases remains, what experience do we have with connection migration? How can we tweak it to make things work better? This brings me back to this point of priorities and our lack of experience and what Martin said right up at the beginning, up-leveling this whole conversation again. I know that multipath is useful in a number of cases, and it's super interesting to work on. We know this. This is something that has value. The question, however, is given that we have a piece of multipath in QUIC, how much does that give us, and how much do we need to add to it, and how do we increase it? I have actually use cases that right now I haven't really figured out if the signaling in multipath is going to be enough for me. And that's something I'd like to see happen, but I'm waiting to get multipath, waiting to get QUIC deployed with connection migration so that I can figure out exactly what more pieces I need. So I would say that we really should have the discussion around priorities of what we want to get done. I really want to see version negotiation happen. That's the first thing I want to see happen next. As a working group, we can keep bringing on more things, but we need to prioritize. And my other point is about just lack of experience. I would love for us to have more experience with connection migration before we decide what more we want to do, how we want to extend the signaling further, how we want to extend our multipath capabilities, which we already have, further.
Thank you. David, please.
I'll keep it short. So what I'm getting from this meeting is we have two main use cases for multipath. One is multipath to a proxy, so ATSSS, and one is multipath end-to-end. So I just want to make a point about each. The first one, so from the discussion earlier, it sounds like there's no clear benefit to end users. And I'm going to quote RC 8890, which came out earlier this year. The internet is for end users. So that's really what we should focus on. So I really don't think that QUIC is a good fit for ATSSS. If the 3GPP wants to work on this, that's good. But if they're asking us to remove encryption and to add complexity, I'm not sure why they're using QUIC in the first place. So I would suggest perhaps using something different, maybe GRE or some other encapsulation between IP and IP. And I'm seeing +1s in the chat. Thank you, folks. Now on the second point, end-to-end multipath. This one, I think, might have value to the end user. The question is, I'm not going to repeat it. I'm just going to agree strongly with Jana. We need to prove that this is better than connection migration. All of the data I've seen so far doesn't take into account connection migration. And then until we do that, I'd say we need to prioritize other work in the QUIC working group, such as the extensions that we have already adopted and probably other things. That's it. Thank you.
Thanks. We may well get cut off in the next few minutes, so I'd like to get through as many people as possible. We'll go with Kazuo next, but yeah, let's try and keep.
I just wanted to make a small comment regarding schedule policies. Well, I agree with Miri that the transport can provide a generic mechanism for from which the application can use some kind of policy or design policy. I would point out that that approach has failed with HTTP2 because the schema is too complicated and only a fraction of the servers implemented things correctly. So I think it would be safer if we move in small steps based on use cases rather than trying to design something generic. That's all.
Thank you. Spen.
Sorry. So I would just real quickly wanted to say experimental was good enough for what I was hoping for from a multipath QUIC. Is experimental not good enough for any? Is there anyone for whom experimental is not good enough?
Okay, moving on. Olivier.
Yes, so I just want to answer Martin and Roberto about where to put multipath. Is it in layer 3 or is it above in the application layer? I think multipath belongs to layer 4 because this is where we have congestion control information and this is where we have retransmission capabilities, and both work together.
Thank you. Yunfei.
So I want to give one comment on the connection migration. So one thing, so we figured that the connection, if you compare connection migration with LTE, right? So can connection migration in QUIC do better than LTE handover, right? Because LTE between the base station there is actual interface for exchanging the context. And so given that for some extreme mobility use cases, I think with multi-path can be better than even the LTE handover. So that's one of the comments I want to make to everyone.
Okay, thank you. And that is the end of the queue from when I cut it. Lars, have you got any closing statement you'd like to make?
Well, nothing than thanking Robin, first of all, who's been taking our minutes. There was a heroic effort. It seems clear that we need to talk
Eric.
more. But Eric, thank you both. It seems clear that we need to talk more. I encourage you to use the mailing list for this rather than GitHub issues or something like that. It's the better vessel. We will monitor the discussion. We'll probably have a follow-up discussion on the list. It's always possible to have another one of these, maybe with more time for discussion than we had. I also encourage people that sort of presented use cases and saw similarities between them to maybe talk amongst yourselves and figure out whether you can consolidate your use cases or come up with some joint proposals for what could be taken forward. But I think this is a hard problem, right? Because it's unclear how much technology. It's too late for me to do this. It's unclear what functionality is missing at the moment. It's unclear whether the stacks that are at the moment getting very large deployments are even interested in deploying this. Some scheduling questions are unclear. What information the application needs to have, what information the QUIC stack needs to have, and so on. So this is a hard problem. And we did multipath TCP, right? It was like a 3-year EU-funded research project, and then a whole bunch of standardization at the end of it, and then a whole bunch of implementation work. We can leverage that to some degree, but QUIC also brings new challenges, and so we need to carefully think what we want to do. I hope we can find something that is small and that will enable experimentation, and that might already support some of the use cases directly that we can start with and then continue to like move forward if this gets traction. I'm hesitant to sort of see us doing a full multipath architecture in like one go. That would be a pretty heavy lift, I think. With that, it's 1 minute past and WebEx hasn't cut us off, so I must have configured it correctly to not do that, which still means we're done. Use the mailing list, talk to each other, talk to Lucas and me, see if we need more discussion time like this. And we'll see if we have some agenda time in, well, I was going to say in Bangkok, but I guess at IETF 109. Thank you all. Good evening, good day, good night, good morning.
Thank you all.